psychology from the New York School for Social Research, New York City, USA. She has many award-winning books. She's also an award-winning international speaker and a faculty member in several medical and anti-aging societies. She is a recognized and honored member of Who is Who. So let's take it up for Who is Who, Dr. Sofra.
Thank you very much. I'm honored to be here, and I want to talk about psychology today, although the previous speaker wrote my book. I'm going to be talking about how we can have endogenous stem cells, how we can actually increase the production of our stem cells and in our system. And this presentation is based on some recent publications that I made. And my friends are here, welcome guys. This is also based on some books that I've written, the books. Now, obesity and inflammation is a sort of a deadly vicious circle. Obesity is the shape of death, pretty much. So it's obesity, it increases inflammation, inflammation increases toxicity, toxicity increases hunger. The more toxic you are, the more hungry you are, and of course, the more hungry you are, the more obese you are. So there are several causes of fatty liver. Obesity is one of them. Of course, we have side effects of meds sometimes, fats in the blood, diabetes. So you have the fatty liver that is associated with inflammation and higher mortality rates, and then you have the healthy living of exercise and healthy living and lifestyle. One is optimal, yeah. And now you have a lot of stem cell therapies, and mesenchymal stem cell therapies are preferable when you're dealing with liver disease because they're far less expensive and much safer than reaching a level that you need a liver transplant or an operation. Some stem cell studies have small samples, so the more the better. We need more stem cell studies, and sometimes they get opposite results. Like with all studies, sometimes we get opposite results. The outcome is higher or lower. Sometimes don't want it to be lower, but it's lower, so it depends. Now, what's mesenchymal stem cells? They are multipotent stem cells that can divide and develop into multiple specialized cell types. And they're a very high quantity in adipose tissue, 1 in 100 versus 1 in 100,000. So in one in 100 cells in adipose tissue are much more frequent in adipose tissue than in bone marrow. And you can also get stem cells from burns, skin-derived mesenchymal stem cells. However, the problem with the burn ones is the differentiation level is much lower. And as we age, we actually have more cells. We increase the number of cells. We have greater proliferation, but we have much less differentiation. And that's why most people get cancer, because proliferation without differentiation is a problem. Now, exercise increases stem cells, naturally increases stem cells. And there's a lot of studies and a lot of research related to that. So, why? Because as the exercise releases the fat in the bloodstream, that goes into the mitochondria, the glucose goes to the mitochondria, it burns through oxygen or lactic acid in the case of exercise, and as a result of that, you have the energy that is produced to build the muscle, to repair different organs, so on and so forth. So, endogenous stem cells are also released into the bloodstream through the adipose tissue. And they go into the bloodstream, and then from there, they're directed to the sites of where they can repair the vital organs. So, now the contents of adipocytes that are naturally released into the bloodstream can provide mesenchymal stem cells, mesodermal ones, endothelial cells, smooth muscle cells, and also hepatocytes. Now, there is about 95 articles with aerobic resistance protocols that demonstrate significant improvement of fatty liver. So the assumption is, okay, so the visceral fat is reduced, but there must be a mechanism that actually repairs the fatty liver. So the mechanism is assumed to be the mesenchymal stem cells that are released along with all the glucose and the lipids into the bloodstream as during exercise from the adipocytes and the fat cells. And this is a slide of the histology from day 7 to 14, and you can see sort of the difference, histological difference. Now, hepatocytes play a critical role in detoxification, in metabolism, and remember what we said before, the more toxic you are, the more hungry you are. And of course, the more hungry you are, the more you're going to start increasing your weight. So it also are involved in metabolism and in protein synthesis in the liver. Now, the adipose tissue cells have a low level of silicates. The hepatocytes are derived from mesenchymal stem cells. They're extremely important because they produce albumin. And that's one of the variables that we like to measure if the albumin is, well, it has to be in the normal range, but it has to be at the kind of highest level of the normal range. That means it's the most optimal, and it cannot be below the normal range. It also contains stroma cells, and the stroma cells is underlined in red here. You can see them. This is the stroma cells, that they're basically the bind cells together, and they're very, very important because they're holding things together. It's like a bag that is holding things, otherwise you wouldn't be able to carry them. So there is a study with 8,862 individuals that are between 40 and 73 years old, and they had fatty liver disease, non-alcoholic fatty liver disease. And what they found is this is the variables that were basically increased: creatinine, aminotransferase, the alanine aminotransferase, aspartate aminotransferase, the AST, and of course they had insulin resistance. What's alanine aminotransferase? That is what causes the jaundice, diabetes mellitus, metabolic syndrome, cancer. So if you have higher levels than normal of ALT, not only liver disease, but a lot of other diseases could be present. A study of 432 patients revealed that fatty liver disease also is associated with, again, the same indices, alanine aminotransferase, AST, also increased triglycerides, diabetes mellitus, and hypertension. And the aspartate aminotransferase, ALT, is an enzyme, again, that is associated with hepatitis, with different liver diseases, heart problems, pancreatitis, diabetes, and so forth. So all these variables are unwanted. We want these variables to be within the normal range. A study of 132,377 individuals, 64,000 plus men and 67,000 plus women, found correlations between ALT, AST, and LP. So this is sort of your protagonist that you want to look for to see if liver disease has been reduced. Now, high ALP levels may cause cirrhosis and tumors and hepatitis, but if you have them below the normal range, there's also another problem because you can have anemia. They can be associated with anemia. So we did a study with 10 people, 10 individuals, a small sample. It has to be replicated. They were all non-alcoholic fatty liver, and the average BMI was quite high, 31.99, 4.99, from 54 to 64 years of age. They were all 5 males, 5 females. All subjects have been diagnosed with pre-diabetes and hepatic steatosis, also sonography reports, and other independent tests, and they received 15 treatments. And we looked at ultrasonography reports, we looked at blood tests of ALT, AST, LP, albumin, creatinine, bilirubin, triglycerides, VLDL, the very low density lipoprotein. That's very important because it's large, so it kind of can block the arteries. CRP, that's the C-reactive protein that has to do with inflammation. Testosterone, cortisol, and we also looked at visceral fat, body mass, metabolic rate, and mass index. And what we found, the results were very significant, statistically significant. The ALT, the average decrease was 24.83%. AST, the average decrease was 30.4%. ALP average decrease was 14.52%, and albumin average increase was 22%, 22.7%. This is the same, the exact same that what I just spoke with bigger, so you can see. All of these results were statistically significant, so that all of the subjects had an increase. Some of them had less, some of them had more, because there is individual differences that vary that. In terms of creatinine and bilirubin, the decrease of creatinine was 19%, 19.67%, and bilirubin was minus 12.33%. These percentages are kind of, they don't mean anything, because basically you don't want to decrease a variable below the normal range. So it depends how high it is. So when you decrease it to be within the normal range. You don't decrease to be kind of much less. Otherwise, there could be other problems, other health problems that come. And now the important thing is that in sonography reports, 80% seem to have liver that appear to be very functional, normal. About 20% had significantly improved on the sonography report. So that was a very good result. Again, this is not statistically significant, because 20% is 0.2. So it's not, it should be 0.1, at the highest, 0.05. So it's not statistically significant, but it shows an improvement. The triglycerides, the VLDL, and the CRP were also decreased. Triglycerides by 24%, VLDL by 23%, and CRP by 33%. But all these people were pre-diabetics. So for a normal person, you're going to see much higher results. With diabetic people, you're going to see even less significant results. I mean, you're going to see a decreased percentage. The results may be significant, but the percentage of improvement is going to be less. The higher the disease, the less the improvement. So cortisol decrease was by 28.68%. That is very important, because high cortisol can have the Cushing's syndrome. Of course, low cortisol, you can have Addison's disease. So, you have again to be within the normal range. That's the important thing to remember. Testosterone, the increase was very high, 50%. We see very high increase in testosterone with this technology. And muscle mass was increased by plus 58% in this particular sample. Other samples had less. This was actually quite high. So again, this is the same results in figures so you can see. And BMI decrease was 19%. BMR increased. The BMR seems to increase quite a lot with this particular technology. And VAT decrease was 33%. This is, all of these values were significant. ALT, AST, albumin, creatinine, bilirubin, triglycerides, VLDL, CRP, BMI, BMR, PhD, cortisol, testosterone, and muscle mass. Now, all of these were decreased. They were all in the normal range. Again, that's what you want. You don't want it to be too high, you don't want it to be too low. You need to be within the normal range, or the upper level of the normal range that is at the peak of the function. Now, so these have important implications that different forms of exercise, including effortless exercise, can release endogenous mesenchymal stem cells. Now, can we see that? Of course, we cannot see it. It's an assumption that we make because you see liver repair, and you cannot have a repair just because the fat has come out of the liver. There must be a mechanism that actually repairs the liver, and the most kind of possible mechanism is stem cells, because this is the mechanism that they have been used. They have been used exogenous stem cells through injections to repair the liver, and that with very good success. And this is another article I just published, and this was a long-term study that was actually happening here in Malaysia, in the Swiss clinic. And what they did is, this is a lower BMI, only 23.2. But these guys did not get a blood test until 7 months later. And initially they were supposed to do it immediately after the treatment, but they only got it 7 months later. They didn't know how to do it. But then I thought, okay, well, we're going to do a longitudinal study then. And only 6 treatments and 7 months later, and this is the results. After 7 months and 6 treatments, the AST, that alanine aminotransferase, was decreased in 100% of the subjects. Okay, we did not get that good results for everything else. This is the best. Okay. Bilirubin ultimately decreased in 100% of the subjects at a statistical significance level of 0.01. The AST had a very high significance level, 0.0001. For some reason, AST remained decreased in all subjects. All of them were within the normal range. ALT was very interesting. About 40% of the subjects had high ALT, and that decreased by 23% to reach the normal range. Now, if you have high ALT, you have liver disease. If you have low ALT, you have frailty and this mortality. So 40% of the subjects had low ALT, and that also increased to be by 32% to be within the normal range. So you see, when you do experimental research, you need to look. This normal range thing can be a headache, because some people can be below, some people can be above, and you have to analyze them separately. Otherwise, your results are going to be confounded, and they're going to not mean anything anyway. So GGT, the gamma glutamyl transferase, also decreased and increased. So about 80% of the subjects with high GGT decreased by 10%, and about 10% of the subjects with low GGT were increased. And again, the 80% of the subjects, of course, I can give you a significant result. The one, the 10%, we cannot look at significance because the sample is too small. But the important thing to understand is high GGT it's going to cause a liver disease. Low GGT is going to be associated with vitamin D, magnesium deficiency, so a nutritional deficiency. The cortisol also was optimized in 80% of the subjects, and 10% of the subjects had to increase the cortisol. Remember, very high cortisol is Cushing's, low cortisol is Addison's. So 10% of the subjects with low cortisol was increased, was normalized. So that's what you want, basically. But again, the 80% will have a significant result, statistically significant. The remaining 10%, we cannot do significance. because the sample is too small. And this shows you the importance of having a larger sample when you have results like that. Otherwise, you cannot get the significance that you want. After an average of 7 months, the T3 significantly increased to 0.5% in 60% of the subjects. This is interesting. What happened with these guys is that they did not follow the nutritional recommendations or the lifestyle. They just did whatever they wanted and ate whatever they wanted. And this is the important thing. So you see that the metabolism is affected by nutrition and lifestyle a lot more than all the other medicines. So because you see only 60% of them maintain a significant result. Everybody else just, the results were like not what you wanted to see. There's also significantly increase in 60% of the subjects, again, 37% in females and 66% in males. But there were very few males in that sample, so you cannot get significance out of that. Again, sample size was a problem. After 7 months and 6 treatments, the basal metabolic rate remained increased in 80% of the subjects. Again, what this tells you is that lifestyle will affect your basal metabolic rate. And waist circumference stayed, they maintained the results in terms of waist circumference, but not that much. It wasn't that high, the CF. So the results of this study shows that exercise can create, and also effortless exercise, which is what we use, can create a long-term effect of health, a long-term health effect after you have stopped kind of exercise. It persists. But remember, it's only 7 months. I mean, what would happen in 10 months or in 1 year? Probably you're going to start going down. I mean, you don't exercise and you have the wrong lifestyle, it's impossible to maintain a health status that is appropriate. So the recommendation is that you must improve your lifestyle. But exercise, and effort exercise, is going to be very important, but up to a point. You cannot reduce weight. So longevity is dependent not only on exercise or efforts exercise, but on lifestyle and nutrition. So that's the message that I want to give you. And this is some of the articles that I have published. It's about 35 now. And with this, I would like to end the lecture. And if you have any more questions other than today, please get in touch with me at science@IELLIOS.com. Thank you. Do you have time for questions or not?
Let me get back to my mic. Yes, we have time for one question, if it's possible. Anybody? Any questions? I guess not.
No, there's no. Okay, thank you.
Thank you. Thank you, Dr. Sofra, for such an interesting talk. Next up, we have